My dear friends, I'm going to discuss today some problems related to the electrical networks. Like number one, when the registers are said to be in series. Number two, when they are said to be in parallel. Number three, certain problems like the filament bulbs, if they are connected in series, which bulb will be more brighter? And if the bulbs are in parallel, then which will be more brighter? What is maximum power theorem? Like that. Okay. If you think my video is good, you understand the concepts, please subscribe and like my channel. It is a request, okay? I'm giving you the WhatsApp number. Find any difficulty, ask me in my phone in the WhatsApp. The number is 9888169226. Don't hesitate. And even then, if you are interested to give a subjective test of 11th, 12th, of any topic, then write me. No problem. Okay? Thank you. Let's come with me. Dear friends, today's our problem is maximum power theorem. We are having a very simple circuit. Battery of EMF E. The internal resistance of the battery is smaller. This battery is connected to an external resistor, capital R. You know, our problem is how much power of the battery can be delivered to R. Your answer may be, you will say 100% of its power can be delivered to R. No, this is wrong answer. Because of the internal resistor. If internal resistance is 0, if R equals to 0, then it is okay. The whole of the power can be delivered to R. But if there is internal resistance, then less power, okay, will be delivered to R. The question is how much power will be delivered. तो मैं आपको हिंदी में समझाना चाहूँगा कि इसकी बैटरी EMF E, इसका पावर है अपना, ये अपना कितना पावर इसको दे सकता है, R, कैपिटल R को. देखो, यदि तो इसका इंटरनल रेजिस्टेंस नहीं है, 0 है, तो ये सारा पावर दे सकता है. पर इसका अपना इंटरनल रेजिस्टेंस होता है, तो ये सारा पावर इसको नहीं देगा. तो कितनी देगा? दिस इज अ क्वेश्चन. ओके, लेट गोइंग टू डिस्कस. Now, first of all, what is the current which is now flowing in the circuit? The current I equals to E upon small r plus capital R. Okay. Then, according to Ohm's law, voltage is equals to I into capital R, where here the voltage across the 2 points. Substituting the value of I, it becomes E upon capital R plus small r into this one. So this is a voltage. Okay. Now you know very well the formula of the power. Power delivered to capital R is, power is I square. Formula of power is I square capital R. Power delivered to R is I square R. But what is the current? Okay, current is E upon small r over capital R. Substituting this current here, so it becomes E square, it becomes E upon small r plus capital R, okay, is a square into capital R, right? This is the power. Now, because our question is when this power delivered, which is the power delivered here, when it maximizes for what value of R? Well, what should be capital R? What should be this value as compared to this one, so that delivery should be maximum, delivered power should be maximum here. So I'm going to take the help of differentiation. dp upon dr equals to 0. Mean if I do the differentiation of power with respect to R, because this power is a function of capital R. This R is our choice. We can change this value. And what the value should be, what should be capital R, so that P becomes maximum. Then that means differentiation gives the answer when you make it 0. When differentiation make it 0, then power is maximized. So maximum power delivered to this register is happened when dp over dr equals to 0. So substituting this P here, substituting the value of P, okay, then it becomes, so dp upon dr, mean E square is constant, because this was the expression, power equals to E square upon R plus R whole square into capital R, okay, and it can be written as E square capital R small r plus capital R raised to power minus 2. Now I'm going to take the differentiation dp upon dr, mean d upon dr here, and this is within the bracket, okay. So this is that expression. So now E square is outside the bracket. Now there are two functions, first function, second function. Second function as it is, differentiation of this. So differentiation of this, it is 1 plus, now capital R as it is, differentiation of this function. So it is minus 2 bracket raised to power n minus 1. N minus 1 means minus 2 minus 1 is minus 3. Then also the differentiation within the bracket. Bracket is capital R plus small r. Now this differentiation is 0 because not a function of this one. So this is 0. Then this dr over dr, it is 1. And we left only this term. Okay. Now you set dp upon dr, this is equals to 0. This equals to 0 means this is equals to 0. When this is equals to 0, it implies, because E square cannot be equal to 0, that means this is equals to 0. And what is this? This is capital R plus small r raised to power minus 2 is equals to minus 2r, not minus, because it is equals to 0 mean equals to, the minus 2 becomes plus 2 because I set this equals to 0. So this factor taken to the right hand side. So that becomes plus 2 r plus capital R raised to power minus 3. So this whole cancel with this one and left power minus 1. This power becomes minus 1. Now here it is 1. Now this factor, which is power minus 1, is taken to left hand side. Then this minus 1 becomes plus. Mean when it goes to left hand side, it becomes r plus capital R is equals to this 2r. So this is taken to this side. It implies r becomes equals to small r. So power delivered is maximum to external resistor if its internal resistance of the battery is equals to this much. Okay, that means if this is the circuit and battery having internal resistance 100 ohm, and if it is also 100 ohm, then this battery will deliver maximum power to this resistor. Now I am finding the efficiency, output power over input power in percent, mean multiplied by 100. What is output power? Delivered to resistor. What is input power? Battery power into 100. So V over E into 100. Okay. Then, you know what is V? You know, V equals to IR, and I equals to, I equals to E upon capital R plus small r. So this is what? This is our V. So substituting this V here, okay, so this is R plus small r is this one instead of V. Then this E is here. This E, it is here. This V is ER upon R plus small r. Okay. Now this E and E cancels out, and it becomes R over R plus small r into 100. So when this R becomes equal to capital R, mean power delivered maximum. So you change R with capital R. So this is 1 over 2. 1 over 2 mean 0.5. 0.5 into 100 mean 50%. So maximum power delivered is 50%, and it happens when small r and capital R becomes equal. Now the last, if your battery is not having any internal resistance, which is not possible otherwise, but you can suppose, there is no question that you suppose that R equals to 0. You can suppose if R equals to 0, R over 1, this is 1, then efficiency is 100%. But it cannot be happened, because every battery having some internal resistor. So efficiency of the battery becomes maximum only if their in external and internal, when external load is equals to the internal resistance of the battery. So this is very, very important. Maximum power delivered to the external load when external load equals to the internal resistance of the battery. Okay, thank you. किसी ने क्या खूब कहा है, जो तूफानों में पलते हैं वही दुनिया बदलते हैं। जो कंफर्टेबल लाइफ में रहते हैं ना, वो शायद जिंदगी में इतना कुछ नहीं कर पाते जितने वो लोग जो बड़े हार्ड लाइफ में से निकल के आते हैं। जो तूफानों में पलते हैं वही दुनिया बदलते हैं, ये याद रखिएगा। प्लीज़ सब्सक्राइब माई चैनल। ओके।